Now, students, we will start with the topic of the curves. Do you know how to get the area of a curve?
You you suck. Oh no.
You suck.
You're a loser. Loser.
Okay, I will explain the topic with an example where two kids are playing with the ball. So, one player throws the ball and the other player receives the ball, and at the moment the player receives the ball, he throws it again, and so on. Where do you think the curve is when the players throw the ball?
I think that the curve is the whole moment when the ball goes up and down.
I think the curve is just when the ball is in its highest point.
I agree with him because the curve starts at the beginning when the ball starts.
Two of you are correct, since the curve starts when the first player throws the ball and the curve ends when the other player receives the ball. So we need to know the equation of the curve. Our curve, just to give it a value, will be negative x to the second power plus 4x equals to y. Since we know our equation, we need to find the position in which each player is located. Let's suppose that the first player is located in x equals 0 and the second player is located at x equals 4. Now, what we have the limits, what will the area be?
I think that the area will be the sum of everything.
I guess that the area is the space covered by the curve.
The area is the space that's inside the curve. As you may already know, when a quadratic formula starts with negative, the curve is like a U upside down, so the space between x equals 0 and x equals 4 will be our area. The area under a curve between 2 points can be found by doing a definite integral between the 2 points. To find the area under the curve y equals fx between x equals a and x equals b, integrate y equals f of x between the limits of a and b. Please, someone pass and do the area of the curve. So what would you think it will be the maximum and the minimum point in the curve?
I think it will be the maximum height and the minimum height.
Yes, I completely agree with Rodrigo.
The maximum point and the lower point are the maximum point and the lower point of the curve.
Yes, you all are correct. When you are doing the equation like this, it's always useful. What is the maximum and minimum point of the curve? Could you look for a tangent line in the curve?
I don't really think that you can find a line in a curve.
Well, I disagree with him because I think that you can find a tangent line.
If you think there is always a counterpart to everything, right?
Yes, there's always something that does the same, but in different ways.
You're totally right. It's like superheroes.
I'm saying it's like Flash. He uses his velocity to good things, but there's another super speedy runner that uses his speed for doing bad things.
So what I'm trying to say that there's also another way to know a point on a curve using a tangent line.
I think that that is impossible.
I didn't follow up. Can you explain more?
Yes, I don't understand.
When we talk about tangent lines on a curve, we use derivatives. We're going back to our first class. Does someone knows its function?
I think that the equation for a line is y equals mx plus b.
You're right, but in this case, this equation will have a few changes. The m, which is the slope, will be the derivative of our equation negative x to the second power plus 4x equals 0 times x, and our y will be the original equation that equals to 0 as well, and the result of both equations will take the value of each place. So, okay class, that's our lesson for today.
I think that that is impossible.
I did not follow up. Can you explain me?
I don't understand.
Se supone que era el maestro.